We're going to continue our study on graphs of radical equations by now focusing on the transformation side. Now, I think you're going to like this because basically transformations, if we understand them, become like a shortcut method. And the good news is we've already studied transformations. So if you want to remember with me a little bit about the transformation that you see with a parabola, what we'll do is we'll connect that to a radical. So here's a parabola. Y equals x minus 3, the quantity squared. Now remember, if you have a number on the inside, that's always going to be a shift horizontally. And specifically, if there's a subtraction sign, like subtraction of 3, that means we would have shifted 3 units to the right. Now, it's very easy to graph a parabola that was shifted 3 units to the right. You mark your vertex, and you draw a parabola. And so we just graph that equation by using transformations. So what will happen if we have a transformation, if we have a transformation on a radical equation? Like what happens if there's an x plus 5 on the inside of a radical? Well, it's still going to be a horizontal shift, but this time, of course, with the plus sign, we know that it would actually shift to the left. So what's a graph of radical going to look like that's shifted to the left 5 units? Well, we'll certainly be able to mark that shift point and draw a radical graph. And from yesterday, a square root graph is always going to have this particular shape. So we just graph that radical equation by using transformations. Now, you don't always have to have a number on the inside to have a transformation. We could have a number on the outside like this plus 2. And remember that that's going to take the parabola and shift it 2 units up. Of course, it's very easy to graph a parabola that's shifted 2 units up. All we have to do is mark that shift point and draw your parabola. So what's it going to look like for a radical equation that has a number that's on the outside? Well, in this case, the square root of x with a minus 4, notice that that minus 4 is on the outside of the square root. By the way, if the square root bar had been longer, then we would say it's on the inside. But since it's on the outside, we'll be able to say that this is going to be a vertical shift down 4 units. Well, it's very easy to graph a square root graph that's shifted down 4 units. We can mark that starting point, that vertex, at 0, -4, and draw your radical graph. Pretty easy to draw a graph if you're using transformations. You just have to remember them. So let's remember one more transformation. What happens if we are multiplying by a number that's in front of the x squared? Well, remember that when you multiply by a number, that it's always going to stretch or compress the graph. In this case, because this number is less than 1, remember, when you have a number that's less than 1, it's going to actually compress the parabola. Now, this particular parabola has not shifted, so it's still going to stay at 0, 0. It's going to start at 0, 0, but we want to draw a graph that looks like it's been compressed. In other words, that somebody pushed down on it. And if you push down on a parabola, it's going to look a little wider. So what if we have a coefficient? What if we have a number out front that's being multiplied that's greater than 1? Well, if the number is greater than 1, it's not going to compress the graph, but it's going to stretch the graph. Now, when we stretch a square root graph, we want to think about the shape that we've been drawing, but we want to pull on it. We want to stretch it. So if we stretch a square root graph, it's going to look more like this. A stretched square root graph has been pulled up on, and so it has a little different shape to it. Now, each of these 3 radical graphs allows you to see a different transformation. Notice again, when you have a number on the inside, it's actually under the square root. Notice when there's a number on the outside, and notice when you have a number in front of the square root. So the position of these 3 numbers allows us to create what's known as the sort of the general formula for any radical equation, where we have the potential to have a coefficient. A lot of times we call that a. That would be in front of the square root. Then we'd have an x plus or minus some value. We'll usually call that h under the square root. And then a number at the end or on the outside plus or minus k. And what we want to remember is that each of these numbers is doing something different. It's doing a different transformation. Now, the good news is these transformations are all the same as what you've already learned. So we'll start with the letter A. Now, the letter A, again, is the coefficient. And remember, when A is greater than 1, your graph is going to be vertically stretched. And if a graph is vertically stretched, as we drew up above, it's going to have a slightly different shape. We could also have a graph that is, we could have an A value that is less than 1. And if the A value is less than 1, then the graph is going to be vertically compressed. Now, I didn't show you a graph of a square root that's vertically compressed, but it would feel like somebody pushed down on it. Now, one thing we didn't discuss is if you have a negative sign. At least we didn't discuss it today. You did see a negative sign in yesterday's lesson. So what if we have a negative sign? Let's start with the one that's on the, in general, actually, if you have a negative sign, it's always going to be a reflection. It's always going to be a reflection. But what we have is the potential to have two different types of reflections. And so let's start with the negative sign that is on the outside of the square root. Now, if you have a negative sign on the outside of the square root, it's actually going to take your graph and it's going to reflect it over the x-axis. Now, if you reflect a square root graph over the x-axis, it's now going to look like it's going down. And so again, that's when you have a negative on the outside of the square root. What if you have a negative on the inside of the square root? Well, if it's on the inside of the square root, it's also going to be a reflection, but it's going to be a slightly different reflection. It's actually going to take the graph and it's going to reflect it over the y-axis. If you reflect the graph over the y-axis, it's now going to be going to the left. And so negative signs can kind of get a little interesting, a little tricky, because there's two different options. So we have to figure out the location of the negative sign first. Now, h is this number that is on the inside of the equation. And remember, whenever the number is on the inside, it's always going to be a horizontal shift. But you do want to remember that the horizontal shift, so to speak, is the opposite of the number. So, of course, if we have a plus sign, it's a shift actually to the left. And if you have a minus sign, it's a shift to the right. The last number is this k value. This number that's at the end of the equation is always going to be a vertical shift. Now, that is not going to be an opposite. It would be the same with the sign. When you get into a problem that has multiple transformations, you always want to do reflections and stretch compressions before you would do a shift. So I always want to think about the shape of the graph. I always want to think about the direction of the graph before I do the shift. And I'll show you how to think about that as we work through this next set of examples. All right, so let's take a look at how we can graph a radical equation using transformations. It's actually, again, you'll find this to be a pretty nice shortcut, but I still want to go through the steps the first time here. You want to look at each number, decide what it does. Here we have a -2 on the inside. So remember, a -2 on the inside is going to shift the graph to the right. Specifically, it's going to go right 2. We have this +7 on the outside. That's going to be a vertical shift up. Of course, specifically up 7. Now, what that does is that gives you the vertex. And the vertex is always going to be the most important point. And in this case, it's easy to find based on the shifting. Now, when you think about the position of 2, 7, it's pretty easy to locate. But it seems kind of strange to draw a graph with just one point, although we can do it. And in fact, I'm going to do it right now because it's the same graph that we've seen many times. What we do is we want to add it. One more piece to this. We want to find another point. And the thing that students sometimes don't understand is that this could be any point, but it can't just be any numbers. It needs to be numbers that match with the equation. And here's where we get back to thinking yesterday about trying to take the square root of a nice number, of a perfect number. Now, taking the square root of maybe like the number 9 would be nice, but if I plug in the number 9, that's not going to give me 9. Instead, what I want to do is I want to plug in 11. Now, the reason I'm plugging in 11 is because that's going to allow me to take the square root of a nice number, of the number 9. And all I got to do is think about that math. Of course, the square root of 9 is actually equal to 3, and when I add 7 to it, I'll end up with 10. Now, a lot of that math you can do in your head, but the important thing to realize here is that I plugged in 11, and I got 10. And again, why did I plug in 11? Well, because I wanted to take the square root of 9, because 9 is a perfect number. Now, the thing about 1110 is that it actually shows up on this graph, and it gives me a second point that I can use to help draw my square root graph. You ready to try this with letter B? Okay, we're going to do the same thing. We're going to think about the transformations. You can think about them one by one, and then we'll end up getting a vertex, and we'll draw a graph with another point. So we have this 3 out front, and of course that's a number greater than 1, so that's going to stretch my graph. It's going to make it look more vertically stretched. We have this minus sign at the end, so it's going to shift our graph down. It's going to shift it down 6. Now, you notice, I hope, that there's no number on the inside. Since there's no number on the inside, what that means is that my vertex did not move left or right. So that means my vertex is still at 0, but since it shifted down 6, it's going to be at 0, negative 6. Now, I can think about another point right now. Remember, it can be any point, but it can't just be any numbers. It has to be numbers that fit with this equation. And so I ask you, what number would you like to take the square root of? Well, you could take the square root of 9, as we did in the other problem, but you could also take the square root of 4. That's a perfect number. You could take the square root of 16. There's different options here. We just got to pick something, and just to pick something different, I'm going to say, why don't we take the square root of 16? Now, what that means is that I'm plugging 16 in for x, and once we work out that math, we'll be able to get the y value. Now, the square root of 16 is the number 4, and once we take 3 times 4 and subtract 6 from that, of course, 12 minus 6 is going to come out to be 6. Okay, so we plugged in 16, and we got a y value of 6. Now, that kind of helps me to get my graph a little bit more sort of lined up. Of course, I'm going to graph 0, negative 6. That's my most important point. That's my vertex. But way out here at 16, 6, at 16, 6, I have another point. And you can see that in order to connect those dots, I have to draw a graph that is much more stretched. It is just a sketch, but the graph is stretched vertically, so everything lines up. Let's do a few more of these together. You'll get an opportunity to do some of them on your own in a moment, but I'd like to show you some more situations. For example, when we have a reflection. Now, it's important to think about the specific reflection. This time it's going to be reflection over the x-axis. What that means is that your graph is going to actually be going in this direction. Of course, that's not going to be our final graph, because after we think about the shape or the direction of the graph, we want to do the shift. And the shift is going to come from the +4. It's a number on the inside, so we have a graph that is actually shifted 4 units to the left. Now, that's going to give you a vertex. Again, if we shifted 4 units to the left, we're at negative 4, 0. I really can graph that right now if I want to. In fact, I can also think about the graph, the shape of the graph going, the reflection of the graph. But we also want to come up with another point, and this other point is basically meant to confirm, to tie everything together nicely, and just to show that you understand the idea of plugging in to this equation. Now, do you understand that we can plug in anything we want, but it's smart to plug in a number that's going to result in a perfect number. So, if I plug in 4, that might not be smart because that's going to give me the square root of 8. If I plug in 3, that's going to give me the square root of 7. But if you plug in 0, now that's going to give us the square root of 4. And basically, the square root of 4 is a nice number. It's a perfect number. It's something that is easy to compute. Of course, it comes out to be 2, but with the negative sign, we get -2. So we plugged in 0, we got -2. Now, could we have plugged in other numbers? Sure. We could have plugged in, if you were thinking about plugging in maybe like 5. Well, that would have given us the square root of 9, and that would have been nice also. But I'd like you to see that what we really found here is the y-intercept. So plugging in 0 sometimes is easy. In this case, it's also helpful because it helps us to see that our graph is actually going in the right direction. That is, that it's reflected and everything ties together nicely. Let's look at one more problem, specifically one that has a reflection. Notice that this reflection is on the inside. This negative sign is on the inside, so this time it's going to be reflection over the y-axis. Now, again, if it's reflected over the y-axis, your graph is going to now be going to the left. It's going to be going in a different direction. But before we actually draw that graph, it would be helpful to also think about the shift. And in this case, the +3 made the graph shift up 3. Of course, the shifting is what always gives us the vertex. So notice that I'm thinking about the vertex. I'm actually plotting it and labeling it. Why don't we come up with a point? Why don't we come up with a point before we draw the graph? Again, that has to do with plugging numbers in. And here, once again, we want to think about trying to do a nice number. Now, if I plug in the number 9, that actually is not going to give me the square root of 9. That's going to give me the square root of -9. But if I plug in -9, now that's going to give me the square root of a +9. Of course, you can't take the square root of a negative number, but you can take the square root of a positive number. So if I plug in -9, it allows me to do the square root of 9. We know that that's 3. And of course, some simple math will end up giving us 3 plus 3. So I plugged in -9, which produced +6. Now, the interesting thing is that point going to make sense? Is the point -9, 6 going to make sense? Well, in fact, it is going to make sense because we know that this graph was reflected. And since it's reflected and going to the left, it's going to have to pass through this point. It does. And for one more time, everything ties together nicely. All right, if you flip the paper over to the back, it's your turn. Why don't you try a couple of these? This is a perfect opportunity to pause the video and try to work out these two problems like you'd be in the classroom. Once you unpause it, then you will see the problem worked out. So try both of them, try one of them, and then try the next one, whichever you would like to do. All right, I'm going to go through this first one. Did you decide that the 1/2 is going to compress the graph? That's a number that's less than 1, so it's going to be a compression. Did you decide that the +6 is going to shift the graph? And of course, it shifts the graph to the left. Now, with those two pieces of information, we can identify a vertex. Since it's shifted to the left, it would be at -6. There is no vertical shift. So I'm going to stay at 0. So we have -6, the point -6, 0 plotted. How about finding another point? There's lots of perfect numbers out there. If you plug in the number 3, that's going to give you a perfect 9. That's nice because the square root of 9 is easy to do. Sometimes students discover that they could plug in the number 10, because again, that's going to give us 16, and that's a perfect number. You actually could plug in -2. If you plug in -2, that's going to give you 4, the square root of 4, of course, and that also is a perfect number. So any of these are a possibility. To show you one answer here, we can do 1/2 times the square root of 4, which is, of course, 2, and 1/2 of 2 is 1. So if I plug in -2, I get the number 1. Now, had you plugged in some other numbers, if you did plug in 3, you found out that your answer, your y value, came out to be a fraction. So that's fine. It's just whatever you chose. I'm going to plug in my -2, 1, and we'll be able to draw a graph that has been compressed. You say, well, how do I know it looks compressed? It's more of just you telling me that you compressed it. Although the graph is a little pushed down, it's not quite as curvy as we're used to. All right, and this other u try. So we have this negative sign. Did you see it? That's going to be a reflection. It is a reflection over the x-axis, which means that the graph is going down. How about the 2? That is going to, of course, stretch the graph. Now, what we got going on here is we got a graph that is actually going down, but it's also been stretched. So to exaggerate that, if I've stretched on the graph, I've pulled down on it. Again, you've stretched it, and the graph is going down, so it's going in this direction. But before I draw the final answer, I'm going to want to think about my shift. And that shift, of course, is going to make the graph go up 5 to the point 0.05. We call that the vertex. And really, this graph that I drew right here needs to be at a different point. It needs to be at the point 0.05. It's still going to be stretched. It's still going to be going down. And we can verify all that with just the right point. And maybe you decided to plug in 9 because the square root of 9 is easy to do. The square root of 9, of course, comes out to be 3. And a little bit of simple math, after you multiply 3 by -2, we get -6. Add a 5 to that, and we come up with the number 1. So that's going to be my other, my output. When I plug in 9, I get 1. Excuse me. Not 1, but -1. So let's adjust that. And when you plot 9 and mark -1. Now, the way that I drew this graph is not really, I overstretched it, to be honest. I sort of overdid the stretch, which is a good reason why it would make sense to graph your other point before you start getting into the business of drawing your graph. So now I can draw my graph kind of looking a little more realistic as it passes through that 0.91. All right, there's actually one more concept we want to do with this idea of transformations, and that is the idea of transforming an existing equation or an existing graph that already has transformed from the beginning. So if you look at this graph here, we want to be clear that it already has had some transformation. I mean, the vertex is at 1, 4. But what we want to do is we want to translate it more. We want to go 4 more units. We want to go 2 more units down. So we're going to do that from the existing point. If I go 4 units to the left, that actually is going to move me to this location. But then, of course, if I go 2 units down, then I will be able to arrive at my final destination. So the idea here is to take the starting point, in this case 1, 4, go 4 units left, go 2 units down, and end up at a new transform point, and you can label that point as -3, 2. Now, the truth is every point on this graph is going to transform. Even the point, if we look carefully here, I believe we can say that there's the point 3, 3. Well, if you take the point 3, 3 and you move it, again, 4 units to the left and 2 units down, you're going to arrive at this new point. It looks like if we label that carefully, it should be the point negative 1, 1. And we could take this point out here. I believe it's the point 8, 2, and we can do the same thing with that. We can move it 4 units down, 4 units left and 2 units down, and that would arrive at the point 4, 0. So can we take something that has already transformed and transform it more? We sure can. It just means moving every point. Can we take an equation? Can we take an equation and transform it? Yes. All we have to do is start putting in the different pieces, the additional pieces. So if I want to reflect this graph over the x-axis, then we're going to have to put a negative sign in front. If I want to shift the graph 3, now it should say 3 more units to the right, then I could subtract 3 more. Of course, that's from the inside. And if I want to shift it 1 more unit up, then I could add 1 more at the end. And so what I want you to see that I'm doing here is that we're coming up with, we're taking what we start with and we're moving it more. So of course on the inside I now have a -5, and on the outside I have a +8. What about this graph? If I want to reflect it over the y-axis and I want to shift it down. Now, you might recall that I said on the front of the paper that you always do reflections first. So I kind of want to think about my reflection. When I say think about the reflection, I can just draw it. I can also take specific points, like maybe this point 4, 6, and I can change it to be -4, 6. But I want to think about the reflection first, and then I want to shift this graph down 2 units. And what that really means is that every point on the graph is going to go down 2 units. But maybe I'll just pick a few of the points that are easy to see, and then I'll be able to draw my, my new graph.